Now we finally get to the last point of this session, which is the API programming interface or application programming interface or API. API is a set of rules that define how applications or devices can connect to and communicate with each other. Generally it provides you with endpoint or address. Usually it's a URL, just like the same URL you will have when you request websites. Then it has a certain set of a method, get, post, etc. And then with a method with the URL, you will always give them some input. Usually it's a JSON in the JSON format. Then you will receive data in the receive in the JSON format. So if we look back at what was in the function application creation, right? We specified some minor details like we need a spot to store our data. We need to use the Python encoding. We need to use HTTP to request. But we never say how many CPUs we want, how many memories do we want. We didn't even specify how many storage we want. All we did was specifying what we want to get. When we set HTTP request, I'm supposedly, if I provided a proper name, I'm supposedly getting a string with my name and some explanation, some more information. And this is the key to the function development. And this is if you think about this is the real really the black box that we've been talking about. I don't care how you do that. All I'm caring is when I give you an input in the JSON format, you will provide me with output also in JSON format, or not necessarily in JSON format, but you get a point. So so the idea is, if all the calculations in the enterprise can be like API, everybody's calling everybody through the URL. That will simplify the architectural design considerations. I don't need to think about servers everywhere. All I'm thinking about is there is a bunch of APIs, each one coming from from a certain team that will provide the information of that team. And that's how different applications and devices can connect to each other or communicate to each other, right? If you look at the example like API, what the API looks like, remember we said get. API have multiple methods. As we said just now, API have multi method. Get, post are the two most common ones. Get is used to, as the name suggests, retrieving data from the URL, from the endpoint. Post is to add data to that endpoint. Then there's also put and patch, which are modifying existing data. And there's delete. Of course, it will delete. So we'll just take a look at the get and the post. For get, you have the app here, right? This is our customer. This is us. We are trying to call an API. We will use a get command and use a link through API address, user ID, etc., and sending that with a this ID equals to 1 or user ID equals to 1 is the parameter we are specifying, just like what we did in function app. When we call that HTTP request trigger, we use the name equal to something. That name equal to something is the input I provide. And once we send this endpoint method and the parameter to the API will provide us with a response, with ID, with the address, whatever I request. So this is get. I send them some information and they will send back information related to this information. Usually it's a query of a certain entities that I want to get the details based on ID or name or certain search criteria. The other most common, the other of the two most common methods of API is post. Post basically is creating information. For example, if I have this endpoint, HTTPS example API v1 user, and I use a post. This post with a parameter of a name and the job. This information will be stored to this API endpoint. So next time when I get so for particularly for this API, it may be returning this message, just say hello world, or your user has been saved properly. Next time, after I do this post, next time when I use get, it will return me this user. So usually what's going to happen is this apparently is an oversimplified model, but oversimplified response. But usually when you run the post, the API will return you a meaningful message like your user has been saved. It will also return some tracking information, like this user's ID is 1 or 2 or 3. Just like when you did the credit card transaction, the other side will definitely give you a tracking number. It's similar here. When you do a post, when you save a username or when you save any information to the endpoint using a post with this information you provided, the API should return you some meaningful information and some tracking information. So the advantage of API-based architecture is basically, as you can see, each API can be developed independently, so they are loosely coupled. This means it's much easier to handle each API than to think in the large architecture, large enterprises architectural level. It's easy to maintain and upgrade. That the API itself is easy to maintain and upgrade. It's easy to upgrade. If you think if you have like worked in enterprise system, any application upgrade is a nightmare. But if you are using an API architecture, upgrading is much easier because it's hidden away. The other side do not understand what your physical implementation is, and they don't need to care. You just upgrade on your own as long as your API is behaving the same way. That's perfectly fine. Nobody will notice. So that also provides a more flexibility in the sense that you can adjust the output and the response style of your API as long as you don't break the previous protocol, previous design. For example, when you post, you can post information like a user job. You can also post like user first name, user second, user last name, and user job and user job title and the language, gender. All these can be posted without any issue. That give you a lot of flexibility. And finally, and because all of this, so API is getting wide adoption. In fact, it's so wide that there's a common pattern, a design pattern, that is called API fabric or API mesh. Azure provide a service called Azure API Management. So API Gateway here it's called API Gateway, but basically what's happening is it help all the users connecting to define different services. For each API, you can define API as a service and register this in the API gateway. And when users try to call you the API, they can just get to API gateway and identify the API and call that API through API gateway. And meanwhile, API gateway itself can do a lot of management work, such as logging who and where is calling a certain API, and if there's a if a rate increase, API gateway can perform certain kind of a rate limiting or IP monitoring or even firewall. So this is Azure's API API-based architecture. We also discussed about event-driven, right? We talked about this event-driven when we talk about HTTP trigger and the blob trigger and the Cosmos DB trigger for the function app. So you can add a trigger to invoke a certain function. Azure Functions HTTP trigger event, that's which we just tried now, or just now, is a one source to one target mapping. You posted a you posted a trigger. You posted a trigger. You posted a URL, and that URL goes to the trigger. Sometimes, though, you may want to centralize the way of event management. You want the all the event come in through the same pipeline instead of getting this HTTP call here and there. If I have 5 functions, each one has a HTTP trigger. Very likely, what's going to happen is I'm going each function receive their URL call, and nobody's controlling that. So Azure has 3 event management systems so that when you have a trigger, that trigger is centrally managed. So these 3 event management systems are Event Grid, Event Hub, and Service Bus. Um, then Azure Storage Account has its own blob event mechanism. So as far as for these 3, Event Grid is for reactive programming and mostly for event distribution, like those events happening once in a while. For example, there's someone saving a file to blob or changing Cosmos DB. Event Hub is for more for big data pipeline, right? Mostly for like telemetry and distributed data streaming. Like if you have a bunch of IoT, you have a bunch of customers, each wearing a smartphone or smart device. Those smart devices are constantly sending you message. So it's multiple streams of data flow, multiple data streams. That's where you can use Event Hub. Whereas the event grid handles status change, like if there's a new data in Cosmos DB or they delete the Cosmos DB, or if there's a new HTTP request coming in. And finally, we have a service bus, which is actually a message queue. That's that's for high value. It's more expensive. It's for high value enterprise messaging, like order processing. When you have all this, they have it, this service bus. It's has some guaranteed perspective. So this is what we. This are the three services that you can use.